Hello everyone, welcome back. Today, we'll learn to solve linear and nonlinear inequalities. So our goal is basically to solve each type. We'll explain what they are and how they're related. So first off, it's a linear inequality. It's the simplest case. So linear inequality is just like a linear equation. Remember, linear equation is however many variables you have, each variable is the first power. But instead of an equal sign, replaced with one of the four inequality signs. So an example looks like this. Instead of y equals x plus 1, you might have y greater than x plus 1, or any one of the four inequality signs. As we'll see, the solution is the entire half the plane basically above or below this line. And then the line itself may or may not be the solution depending on what the inequality sign says. So let's take a look specifically at that one over here on the right. Have explain what it means to be a solution. So remember, solution is anything we can plug in and make this a true statement. All right, so let's look at our first example. All right, so let's do this one. Y is greater than x plus 1. All right, so first off, let's just graph. So these are our first step. I want to graph y equals x plus 1. Okay, and that's essentially going to be our dividing line. So let's graph this. Okay, so of course, here is the, think about the y-intercept. You plug in 0 for x, and y-intercept is 1, so it goes to the point 0, 1. Okay, and then it looks something like this. All right, there's a slope of 1. Okay, now, so that, in this case, is our graph of that. Now, let's think about a few points. All right, let's pick a couple points that are, let's try to have one point that's on the line, 0, 1. Let's also pick a point or two that are not on the line. Okay, so let's pick something simple. Let's pick something, it can be anywhere. Okay, let's pick something kind of below the line right here. Let's pick something basic like 1, 0. Okay, it could be anywhere below the line. Let's pick something simple. Let's pick something above the line. How about 1, 5 or something like that? All right. And what we want to do then is take a look and see what happens when we actually evaluate, plug these into our relationship here. Okay, let's check these. Let's actually do this over here. Let's see what happens. So we're going to check the first one, 0, 1. Okay, so we're going to plug that into this relationship. Okay, and into their inequality and see what happens. Okay, so y is 1, and that's greater than 0, or x is 0 plus 1. So you get the statement 1 is greater than 1. Okay, obviously that's false. That's a false statement. Okay, so what that means, so we'll just say so that point is not a solution. So remember, a solution is anything we can plug in that makes this a true statement. So obviously that's not a solution. Okay, that point on the line in this case is not a solution. All right, now let's check the other ones. Actually, let me housekeeping here. Let me extend this line. Actually, let me draw that line again. There we go. Okay, now let's check the other point. It doesn't matter which one. I'll just check 1, 0 first. So we do the same thing. I want to plug in the point 1, 0 and see what happens. Okay, this time y is 0 greater than x is 1. That's 1 plus 1. So this time we get 0 is greater than 2, which is also a false statement. Okay, so once again, that what this tells us, then the point 1, 0 is not a solution. Just abbreviate that. All right, and finally, let's check the other one. So let's check the other point. Remember, I kind of picked these points at random. The main thing is to demonstrate this. I picked a point on the line, I picked a point below the line, y equals x plus 1, and above the line. Okay, let's check the last point I picked, 1, 5. All right, so plug this in. And so y is 5 greater than x is 1 plus 1. This time we get that 5 is greater than 2. Obviously, that is a true statement. Or not, let me say statement, just simply say this is true. Okay, so what does it mean if it's true? That means this point is a solution. Okay, so what all this means, what all this is going to tell us is that actually, if you plug in any point on the line, it's not a solution. You plug in any point below the line, it's not a solution. If you plug in any point above the line, will be a solution. Okay, so our solutions, so the line y equals x plus 1 is not part of the solution. And also our solutions are above the line y equals x plus 1. Okay, so the way we're going to demonstrate that, and we're going to show that, so I can kind of squeeze this in right here. So what we're going to do is we'll draw our line with a dotted line. Okay, so a dotted line indicates it's not part of the solution. I mentioned that over here. So we're going to graph the line, and basically if the line, the way we're going to tell whether it's not a solution or not is if there's no or equal to part, automatically that tells you it's not, the line itself is not part of the solution. Okay, we just did this to demonstrate why that's true. But anytime you don't have the or equal to part, it's not part of the solution. Okay, and then base our solutions are above this line. I'm just indicate it like that. Okay, so this is the solutions for y is greater than x plus 1. Okay, now let's take a look at Desmos. We can demonstrate that better with Desmos. In fact, Desmos will actually graph inequalities like this for you. Okay, so obviously we know we can graph lines y equals x plus 1. Okay, but we can actually also graph inequalities. Let's just do the inequality we have. Okay, and it actually shows you this right here. So it puts, since we don't have the or equal to part, it actually puts the line itself as a dotted line, indicating it's not part of the solution, and a shaded region is our solution. Okay, now see what happens if I change this. What if I make this greater than or equal to? And one way to do that is either type in greater than equal to. Okay, makes that a solid line, indicating the line is part of the solution. Or I can also do go to the keyboard, I can do a greater than symbol down here. Okay, now what if I turned it around? What if I made it less than or equal to? Then once again, the line is part of the solution since we have the or equal to part, and then the solutions are the region below. Okay, and then if I just simply make this less than that, then as you see, once again, it's the same, except now the line is not part of the solution since we don't have the or equal to part. Okay, so actually Desmos can do this for us as well, which is useful. But I want to show in general how we can determine this is basically do test points either above or below the line. So if you don't have a graphing tool like Desmos available to you, which you can do this, what you do is, once again, if you don't have the or equal to part as part of your inequality sign, the line is not part of the solution. So you put a dotted line. If it is part of the solution, you put a solid line. And then they should pick a test point on either side of the line. And from that, then determine whether the line is which side. So basically, pick a test point, essentially as we did here. So for example, in general, we just pick one point. Let's say like if we picked this point here, 1, 0, and plugged it in, we said that's not, gave us a false statement. So that wasn't a solution. That means the solutions are on the other side. Okay. Or if we picked 0.15 to begin with, we found that gave us a true statement. That means the solutions are on the same side. And I say that here. Okay. So pick a point on either side, not on the line, plug it in the inequality. The result is true, then that half of the plane is the solution. If it's false, the other half of the plane is the solution. Okay. And that's how we're going to solve these linear inequalities. Now, let's take a look at another one or two. So number 2. Now we can also solve ones that are written kind of in a general way like this. What if we had 2x plus y is less than or equal to 5. Okay. Now, I want to graph that. Um, so first, let's graph the line. 2x plus y is equal to 5. Okay. And now the line is going to be, if we graph that, we can just subtract 2x on both sides. This is pretty easy. And then y equals negative 2x plus 5. Okay. Now the graph is going to be a dotted line, actually be a solid line. Okay. Give me a solid line. Since we have the or equal to part, that means the line is part of the solution. Okay. So let's graph that. And it's basically going to look like something like this. So we don't have to give too much detail. But our y-intercept, you plug in 0 for x, is going to be 0, 5. Okay. And we have a negative slope, negative 2x. So it looks something kind of like this. Okay. Once again, this is a solid line. Okay. It's part of the solution. Now let's pick a test point. Easiest thing to pick is 0, 0. Pick anything you want. Okay. Or a test point. Okay. 0, 0. So plug that in. Once again, plug it in the inequality, not the equation, in the inequality, which is going to be 2 times 0 plus 0 is less than or equal to 5. Okay. And so this entire side is 0. So if 0 is less than or equal to 5. Okay. Now, obviously, that's true. Okay. Then the solutions are on the same side as 0, 0. As the origin. Okay. So our inequality looks like this. That's the solution. The line itself and then everything below the line. Okay. And then once again, if we got a false statement, then the other half of the plane above the line would be the solution. Let's graph this one as well on Desmos. We'll just or just turn that one off. So 2x plus y is, I want to say, greater than or equal to 5, or less than, or I forgot what I said. Is less than or equal to 5. Okay. So you can do just, to also type less than or equal, just do less than, then type equal, then 5, and it shows just that. Okay. The line is a solid line. It's part of the solution, and the solution is basically below the line. Okay. On the same side of the line as the origin. You want to think of it, it's above, below, the same side. Okay. Now let's do one more of these. Okay. Squeeze into here because we do number 3. Let's do something where we have something like this, a vertical line. X equals negative, or it's not equal, x is, let's see, how about greater than negative 2? Okay. Now, let's graph x equals negative 2. Okay. Now, this is going to be a dotted line. Okay. And let's put it over here. It's going to be a dotted line. Since we don't have the equal to part, it means the line itself is not part of the solution. Then pick a point on either side of that line. Let's just pick 0, 0, pick something simple. Okay. So test 0, 0. Okay. Plug it in. So here, of course, there's no y, but x is 0. So 0 is greater than negative 2. And that's obviously false. Oh, wait, sorry, that's true, actually. Sorry about that. Yes, remember being greater than here. Remember, greater than means to the right of on the number line. So 0 is greater than negative 2. That's true, rather. We're not talking about absolute value. We're talking about where it is on the number line. Number line 0 is to the right of negative 2. And so then our solution on the same side. Okay. So our solutions are basically this half of the plane over here. Okay. And once again, let's look at that. So here, Instead of thinking above or below, this case, thinking to the right or the left, but basically the solutions are on the same side as 0, 0. Okay, so let's look at that. So I said x is greater than -2. Yeah, exactly the same thing. Okay, now let's talk about nonlinear inequalities. So to solve a nonlinear inequality, I actually realize that I'm going to make this inequalities. Doesn't matter, but so a nonlinear inequality is basically anytime you have a nonlinear equation with one with the equal sign replaced by one of the 4 inequality signs. Okay, remember nonlinear. So linear means all your variables that are there to the first power. So nonlinear simply means that at least one variable is not the first power. So it could be, in this case, could be squared. It could be any power other than 1. Cubed. You could also have like the square root of x, or both be squared, both be different powers. The main thing is all your powers of your variables are not the first power. That's what it means to be nonlinear. Or I also have variables in the denominator, which same as a negative power. Okay, so solutions. Let's look at this example here. So in this similar way, solutions are basically going to be on one side of the other of that graph or that line. In this case, if we do this example, y is equal to x squared plus 1, which is a parabola. Okay, and once again, the line of the graph may or may not be the solution, depending on once again the same thing, the inequality sign. So let's take a look at that in a similar way. Okay, so let's look at that as our first one, number 1. Y is greater than x squared plus 1. Okay, we're going to do the same kind of thing. All right, so first, I want to graph y equals x squared plus 1, which is a parabola. Okay, let's do that over here. Now, this is also going to be a dotted line. Okay, for the same reason we had before. If it doesn't have the or equal to part, it's a dotted line, meaning that the graph itself is not part of the solution. Okay, so it looks something kind of like this. Okay, y equals x squared plus 1. All right. Now, in the same way, we're going to pick a test point just like we did before. Okay, so once again, I'm just pick the origin. Let's actually pick something else. Pick something a little bit different. Now let's just do the origin again. We may look at a couple points anyway. So 0, 0. Okay. Then once again, it's going to test 0, 0. Works exactly the same way. Plug that in. So y is 0 is greater than x, which is 0 squared plus 1. So we get that 0 is greater than 1. Okay. Now, obviously, that's false. And so if it's false, what does that mean? Well, if it's false, that means the solutions are on the other side of the graph. Okay. If been true, the solutions would be on the same side. This means the solutions are on the other side of the graph. Okay. And so basically the solutions are above the line y equals x squared plus 1. Okay. Now, also, if you plugged in a point above this line, maybe like a 0, 5 or something like that, you would have gotten a true statement. Okay. And also, if you plugged in a point on the line like 0, 1, you can try this on your own, like the y-intercept. You plug that in, 0, 1, you'd also get a false statement since points on the graph are not a solution themselves. And that's what our solution looks like. Okay, so let's take a look at that. Let's get with Desmos. So let's turn this one off. So we have y greater than x squared plus 1. Yeah, exactly as we said. So let me zoom in a bit. All right. So once again, the line itself is dotted, meaning the line itself is not part of the solution, but what's above is the solution. Now, in the same way, if we change this around, if I made this greater than, less than, it would be everything else. Okay. Just everything below or everything on the other side of the graph. And then once again, if I did like greater than or less than or equal to, so just do less than and hit the equal to button, The line is now solid means the line is part of the solution. So everything works the same way as it did with linear inequalities, except we have something that's not linear, okay, in this case, a parabola. Okay, let's look at one more example. One is a bit different just because it's actually a closed graph. Let's look at a circle. So I think I can squeeze this in right here. So number 2 of these, this thing started with 1, yeah, number 2. Okay, so what if we have this? X squared plus y squared is less than 5, but less than or equal to 5. Okay. Now, the same thing. So once again, this is definitely nonlinear. The same thing. So on a graph, replace this with equal sign and graph x squared plus y squared is equal to 5. Okay. And now this is going to be a solid line for the same reason. We have the or equal to part. It means it is part of the solution. Now, if we graph that, that's actually a circle centered at the origin. Okay. And with a radius of 5. Okay. So this point right here is going to be 0, 5, 5, 0, negative 5, 0, and 0, negative 5. Once again, it's centered at the origin as a radius of 5. Is a solid line because we have the or equal to part. So once again, we just said we want to pick a point, test point, either inside or outside of the graph. Okay. So let's pick a test point. Once again, how about just use 0, 0? Just can't be anything on the graph. That's the only restriction. Your test point can't actually be on the graph. Okay. Let's test 0, 0. Could be any point you want, but 0, 0 is easiest to use. So I pick it when I can. All right. So plug in 0 for x and y. 0 squared plus 0 squared is less than or equal to 5. That 0 is less than or equal to 5. That's a true statement, obviously. 0 is less than or equal to 5. Okay. So solutions in this case is basically here, it's not essentially above or below, right or left, or on the other side. Solutions are on the same side as the origin. Our solutions are on the inside of the circle. So solutions are inside the circle and also including the circle. Okay. I'll say and including the circle. Okay. And so basically our solutions are, once again, we have a solid line indicating the circle itself is part of the solution. And then this. So if you picked a point on the circle, like 0, 5, plugged it in, you get a true statement. In fact, what you get would be like, would probably be 0. Oh, crap. I'm sorry. I just realized I made a mistake. So wasn't being careful enough. So actually, technically, that's not 5. That's the square root of 5. I'm sorry about that. I wasn't thinking what I was doing. So actually, this goes from 0 to the square root of 5. So I should have picked something made it easier, but that's okay. But this actually is negative the square root of 5. That's right. You plug in the square root of 5. What you get would be 5 equals 5. You plugged in a point on the circle. And 5 equals 5 is true because it means less than or equal to. As long as one of those is true, the whole thing is true. Okay. So let's look at that with Desmos. And so x squared plus y squared is less than or equal to 5. So less than or equal to 5. All right. Now, once again, if we made that just less than 5, okay, that would indicate the circle itself is not part of the solution. Or if we made it greater than 5, it'd be the outside, okay? In that case, everything outside or further than 5 from the origin would be your solution. Okay, so what we learned today then is basically how to solve, at least in 2 dimensions, linear and nonlinear inequalities. Basically, you have to graph them. And so what we've seen, or what we've learned, is that your graph, whether it's a line or other kind of graph, is basically if it doesn't have the or equal to part, it's not part of the solution. Use a dotted line. If it does have the or equal to part, it is part of the solution, and use a solid line. Then basically your solutions are either on one side of the graph or not. And so basically pick a test point, either the only rule for the test point, it can't be on the graph itself. Pick on one side or the other, and then that test point, whether the result is true or false, tells you whether or not which side the solutions are on. Thank you. Have a good day.